In the beginning, our entire universe was compressed in a single point of pure energy smaller than a single atom. Space and time expanded in all directions at the speed of light and beyond at 13.8 billion years ago, giving birth to all the matter and all the energy we know today. That energy was converted into a high-energy plasma, called quark-gluon plasma, roughly a few millionths of a second after the Big Bang. Fundamental particles like electrons and neutrinos began to emerge. Quarks combined into protons and neutrons. After about 3 seconds, the first hydrogen atoms were formed as deuterium. Deuterium is a strong evidence for the Big Bang theory because it couldn't be formed otherwise, so all deuterium must come from the Big Bang. The universe was now primarily a mix of hydrogen nuclei, helium nuclei, electrons, and photons. The cosmic microwave background comes from 380,000 years after the Big Bang. As the universe expanded and cooled, came a period called the Dark Ages of the universe. Because there was no light, gravity pulled and heated clumps of gas and formed the first stars. The first galaxies were predicted to have been formed at 400 million years after the Big Bang. But with recent evidence from the James Webb Space Telescope, galaxies must have formed much faster than previously thought. But that's a topic for another video. During most of the lifetime of a star, it fuses hydrogen into helium. When the hydrogen of a star runs out, fusion slows, gravity compresses the core and its temperature increases, fusing helium into carbon. Then the same process happens again and again, fusing carbon into neon, neon into oxygen, oxygen into silicon, and silicon into nickel, which then decays into iron. Fusion beyond iron consumes more energy than it releases. Stars are born and die explosively. When massive stars, at least 8 times the Sun's mass, reach the iron stage, their cores collapse under gravity, triggering a supernova explosion. During the explosion, elements heavier than iron are formed, giving rise to the elements we see in the periodic table up to uranium, and spread in a cloud of stardust, a nebula, which contribute to succeeding generations of stars, planets, asteroids, and comets. This is another entire topic for another video. Our Sun was born 4.6 billion years ago from the nebula debris of a previous supernova. This is why our solar system contains elements like carbon, oxygen, iron, and even trace amounts of uranium. A legacy of ancient stellar deaths. And everything we see is made from this stellar cloud substance. As Carl Sagan said, we are made of star stuff. Give a like, share, comment, and subscribe.